In this recording, we're going to learn how to solve linear systems using linear combinations. Another way of saying linear combinations is elimination. So let's write that in here. Okay, so that's another synonym, and other times they call it the addition method. But basically the gist of this method is that we've got these two equations that have two unknowns, and it would be a lot nicer if we could get them down to just one equation with one unknown. So it turns out if we can get one of the variables to have opposite coefficients, like you see here, we have 3 and negative 3 as the coefficients of y, and we add the equations, what's going to happen is the 3 y's are going to add to 0. So we'll end up with something like 6x equals 24. Okay, so we've essentially gotten rid of the y variables so that we can solve the equation for x. Now, of course, you can take it from there, right? You can solve that equation and figure out that x has to be 4. So let's divide by 6. Okay. Once you know what the value of one variable is, you have either equation that you can use to solve for the other variable, in this case the y. So I'm looking at these two equations. I have my choice. I can use the top one or the bottom one. Both will work. I like the top equation for the reason that it has all positives, and sometimes we make less mistakes with positives than negatives. So when you have a choice, make it easy on yourself. So I'm going to substitute in place of x. I'll use colors to show what I'm doing here. I'm substituting the 4 in place of the x, because that's what the top equation says. I'll write the rest of the top equation. Okay, now it's just solve out to find out what y is. So do the math here. Okay, now when I subtract 16, I don't end up with any y's. I don't end up with any numbers on the right-hand side. So 3y equals 0. And the only number y can be, when I multiply it by 3, I get 0, is y has to be 0. Okay, so those are the two values of x and y. And because it's an x and a y pair, I can really write it like this. 4, 0. Let's circle that. And let's verify that we have this solution for both equations. So that's our first equation, and then our second equation. Okay, so what I'd like you to do is make substitutions of 4 for x, 0 for y, in both equations, and verify that it checks. So do that substitution, then play the recording when you're ready to check your answers. Okay, so hopefully you paused and worked those out. Excellent, so they both check. Number 2 adds a degree of complexity because, as you can see, we can't simply add the x's to have them add to 0 or the y's. They don't have opposite coefficients. But we're in control here, right? We can manipulate, as you saw in the previous recording, one or both of the equations to get them to have opposite coefficients. So I'm going to multiply the top one by 4, okay? So if I multiply the top equation by 4, I'm going to have a negative 4 as the y coefficient in the top equation. And it will be the opposite of the 4y in the bottom equation. Okay, let's rewrite what we've got in the top equation. So that's my top equation. And the bottom equation just is what it was. So you want to verify here that we didn't make any multiplying mistakes, that we distributed this 4 to both of the terms in the left side, and that we remembered to multiply the right side by the same factor of 4. I think we did so. So having done that, we can now add the two equations. Those add to 0, great, 6x equals negative 12. Okay? And I think we can see what goes on for the x. See if you can take it from there. I want you to solve for x, and then use either of the equations to solve for y. And play the recording when you're ready to check your work. Okay, so hopefully you paused and worked out. It's going to work out that x is 6. Excuse me. When we divide by 6, x is negative 2. Okay, so that's one of our roots, our solutions. And now we just need to find y. Pick your favorite equation. Let's see here. Well, could work with the top one or the bottom one. You know, I said before I liked positives. I also like coefficients of 1. So I can maybe use the top one in this case. So I just have a negative 2 minus y equals negative 5. Okay, so I think I've got my solutions here. But again, we're human beings, we make mistakes, so let's verify. So on your own, just do your checks. Play the recording when you're ready. So hopefully you paused and did checks. If not, please do that now. All right. Our last example that we're going to look at involves doing something to both equations. So we're going to skip ahead to number 4. Skip ahead to number 4 on the next page. We'll leave number 3 for later. Number 4 presents a little problem. First of all, the equations aren't lined up well to work with elimination. Now you might say, well, I could do a substitution here, right? I could divide by 2. You could. Well, let's try to get it set up for elimination. Let's add 5x to both sides in the bottom equation. I'm going to go ahead and rewrite that pair of equations. So I'll rewrite the top equation. Just as is. The bottom equation, now I'm going to be careful to line up like terms, right? It's helpful to see it that way. So as I added 5x to the right side, that's gone. So I have an equal 12 on the right. But over on the left, I've got 5x plus 2y. Okay, so at this point, I want to have a situation where, let me get rid of that line there. I want to have a situation where these are opposite, or these are opposite. Now, I can multiply by anything I like, as long as I multiply both sides of an equation. But I think I'm going to multiply the bottom equation by a negative 1. Okay, because what I want to have is a situation where these are opposites. The y's are opposite signs. So doing that, the top equation stays as it is. Again, I'll rewrite it. Now I'm going to distribute this negative 1. So I end up with negative 5x minus 2y equals negative 12. Now I have a good situation. I have a variable with opposite coefficients. Those add to 0, right? That's great. Now I have an equation with just x's. See if you can take it from there and solve for x, and then solve for y. Play the recording when you're ready. Okay, so we'll go through this kind of fast. We've done a few of these. At this point, I can use either equation to solve for y. I'm going to use that bottom equation. I think it's going to work out well because I already have it solved for y. Okay, so I've solved for y, and I solved for x. I think I have my solutions. I just need to verify that it all checks out, right? Let's go over and do our checks. Play the recording when you've completed your checks. The final example I'd like to look at involves a little more complicated pair of equations here, in the sense that I'm not going to be able to get by just multiplying one of the equations by a number in order to get them to have opposite coefficients. So if you could just add this little example 4b, maybe call this one 4a, You just tuck this one in here. We're not going to really solve this one, but we are going to just set it up so that we could solve it, okay? So I want you to have that flexibility. So if I'm looking at this, I would like one or the other of these variables to have opposite coefficients. I would like either the x's to have opposites or the y's. Your choice. Because the y's have smaller numbers, I'm going to go with that. And so essentially I'm thinking about what coefficient can I get that 2 goes into and 5? And hopefully you're thinking, oh, 10, right? So what could I multiply the top one? So I could be like 10y and the bottom one to be negative 10y. Because if I can do that, I can take it from there, right? So think about what you'd multiply the top one by, what you'd multiply the bottom one by to get that to happen. Play the recording when you're ready. So hopefully you considered something and you said, well, I got to get the top one by 5, right? Because I want 10 in the y. So I'm going to distribute a 5. I got to multiply the right side of the top one by 5 as well. So I'm going to have a 35x plus 10y equals negative 15. Now the bottom equation, I got to think about what I multiply the bottom equation by. So think in your head, pause, think. Hopefully you considered what could you multiply the bottom equation by so that you would have a negative 10y as the coefficient. Hopefully you said negative 2. Or I can multiply each equation by a different value so long as I'm multiplying both sides by the same value. So I'd have a negative 16x minus 10y, and on the right side, negative 4. And I know you can take it from there. These will add to 0. Those will add up. You'll have what? 19x equals negative 19. X is negative 1. ... We could find y. Thanks for watching.